Hi, everyone. My name is David Seidman. I'm a product manager in Google Cloud, and today we'll be doing a deep dive on data protection capabilities in Compute Engine and persistent disk. So what we'll be covering today will be a general overview of this area, and then some depth on what we do around backup and disaster recovery, a new capability we're introducing called disk cloning, capabilities for high availability, workload consistency, and then a set of best practices that you can apply to your workloads. This is a 300 level session. There'll be some technical depth on some existing features, some new features that we are announcing, and again, in the context of best practices, how to choose the right tool for the job so that a particular feature or particular even feature flag is the right choice for whatever your scenario is. So in terms of our mission and who we serve, our goal is to serve the most demanding workloads. So workloads with demanding recovery point objectives, recovery time objectives, workloads that demand flexibility, whether it's around cost or data sovereignty or performance. And the capabilities that we'll be talking about today are a foundation for critical services, both inside of Google and also across many different industries. You can see here some examples: energy, retail, media, finance, the list goes on. So this is a foundation that we bet on and that also customers use across many different industries. So as a high-level overview, starting with scenarios, kind of think about the world in terms of some major functions or scenarios. For backup and for disaster recovery, we have highly reliable, high-performant snapshots, and we'll be talking more about those. If the goal is flexibility for data mobility, copy data management, we'll talk a lot about what we mean by that. But for example, very quickly getting data from production to staging, or very quickly moving data from a production workload to kind of a scratch environment where you can do auditing or verification. Disk clones are the recommended feature for that. For high availability, we have a product that's been GA for since early 2019 called Regional Persistent Disks. We'll talk a lot about how we think about HA. And then for application consistency, we have two new features, Google Machine Images and Guest Flush. Guest Flush is actually an existing feature, but we've made some enhancements to it that we'll be talking about. Okay, so some more depth on snapshots. So snapshots provide resilient backup for failures that could be within the region or within the service. So what we mean by that is if you have a persistent disk running in a certain region, a snapshot allows you to extract that data, and the snapshot is created in another region, and it happens to be stored actually in a different service from persistent disk, stored in GCS. So that means even if there's a failure in or some sort of outage or accidental issue with your disk or with that region or even with PD overall, the data is highly protected. And there's a lot of options here. So for example, by being able to put a snapshot in any region or multi-region, you could optimize for cost. You can optimize for resilience. For example, putting your data on a different continent. You can optimize for performance by keeping your snapshot close to the disk in the same region, optimizing for how long it takes to create and restore that snapshot, or data sovereignty. So if you need to keep your data in Montreal or in a certain jurisdiction in Europe, you can choose exactly which location the snapshot is stored in. I talked a little about some of the agility. If you have a disk and you wish to take a snapshot of it, that snapshot will go to any region or multi-region you select. And if you have a snapshot in a region or multi-region and you wish to restore it to a disk, that can directly be used to create a disk in any region. In terms of thinking about performance for these workflows, it's important to know that once you create a disk from a snapshot, those disks will run at full performance, full speed, as soon as the snapshot restore completes. Whatever I/O throughput latency that you need for your critical workloads will be there once the disk is available and attached. So you don't need to worry about, for example, having an attached disk, which sometimes is performing and sometimes may not be performing well. And in general, as a basic principle, the more data that you're moving to create or restore snapshots, the longer it will take. If you have a very large disk that you're taking a snapshot of for the first time, or that you're restoring, that will take longer than an incremental snapshot that you're capturing more frequently with just small data changes. So let's talk a little about consistency. So as a new area here that we'll be talking about, something that's coming soon and something that's now in beta, we want to ensure that in addition to the crash consistency that snapshots provide, if you need some additional level of consistency, either across disks or up to the level of the guest for your application workload, there's options for that. So the guest flush flag has been available for a long time for snapshots, but for Windows only, integrating with Windows VSS. What we're introducing coming soon is support for this flag on Linux. And the way it works is it integrates with script hooks. So within the guest that has the disk attached that you're snapshotting, you can create or place a script that executes before the snapshot is taken and after the snapshot is taken. So that can provide a lot of flexibility, a lot of control inside the guest. So for example, you can quiesce an application before the snapshot is taken, and then you can unquiesce it after the snapshot is taken. You can trigger automation. You can run scripting to figure out what kind of applications are running on the guest so that you have visibility for, let's say, any cataloging or additional verification you want to do for those workloads. How exactly what those scripts do and how this flag works for those script hooks on Linux depends on the behavior of the script themselves. So the consistency or other behavior is entirely up to those scripts. And this can be provided either by something that you roll your own, or you can work with your favorite backup or disaster recovery provider that we partner with for those scripts. Another feature in this same category is Google Machine Image. This is now in beta, so this is available for anyone to use. Google Machine Image, sometimes called GMIs, provide a point-in-time image of a full instance. So that means VM configuration and data from multiple disks. So if you're running a workload on a VM and the data on multiple disks that are attached has some sort of dependency on one another, let's say data as well as the transaction logs for that data that should be kept in sync, when the Google Machine Image is captured, it's captured consistently and atomically. So this is great for instance replication, backup, restore, or even putting a GMI into the marketplace. Again, it captures disk data as well as the metadata consistently. And you can use this in conjunction with guest flush so that you get consistency both across the disks on a VM as well as up into the workload. Okay, let's talk about a new feature that we touched on a little in the introduction. We are now providing a capability we call disk cloning. So the reason that we've introduced this capability is there's often scenarios where you may have data on a disk. Let's say it's running disk in production, and you very quickly want to create a new disk from the data on that source disk. So today there's a few ways you can create disks. You can create a blank disk. You can create a disk from an image. You can create a disk from a snapshot. This provides an additional way. So, for example, if before you had a disk and you just wanted to create another disk in the same zone, you would have to create a snapshot and then restore the snapshot down. So you're moving data basically up and down through just a temporary sort of placeholder snapshot where you may not, in practice, actually need that snapshot to be a durable backup. So just moving that data could be very slow if you're moving, let's say, tens of terabytes of data. That could take a very long time. Disk clones are optimized for performance and for this exact scenario where, again, what you want is a disk. and in particular, a disk in that same local zone where you're running that workload. And you can expect this to typically complete in a minute or less. So we talked about scenarios of quickly bringing up a staging environment from production. If you are running a workload or a database and want to run some kind of verification, let's say on, or do some sort of export of data, rather than running that export and sort of walking the disk while it's still attached and supporting your production workload, you can now clone it, attach it to a second VM, and then do whatever verification or processing or exporting you want on a completely separate cloned system. For these scenarios, this is also a cost saving. So if the goal was to create a second disk anyway, now you're saving money on the snapshots that are no longer needed. The clone disks are, in many ways, ordinary disks. So they're live, attachable, fully provisioned, writable disks. They run at full speed. There are some constraints. So I mentioned disk clone must be in the same local zone. And it also needs to be of the same type, so the same disk SKU. So if you have an SSD disk, you can clone it into an SSD disk, not an HDD disk. And this is also designed for high frequency. So you can clone a disk every 30 seconds. And again, you can expect the actual cloning process to be high performance. This is just a visual of one of those flows. So again, if you're taking those one-off snapshots today for a high-value disk just to create additional disks, again, for dev test, export, audit, now those one-off snapshots are not necessary. And another scenario, if you are, let's say, scheduling downtime for a workload in order to do an upgrade, now you can have much more protection with higher performance. So the scenario here would be take a clone of a disk, save it as a rollback point. So if you're worried about the upgrade, let's say, being unsuccessful or corrupting the application in some way, and you really want that safe, intact rollback point of before you try to change your application, you would clone it, stop the workload, do whatever upgrade is needed, verify, and if the upgrade succeeds, you can discard that clone. You don't need it anymore. But if it fails and you want to get your upgrade running and you want to get your application running again as soon as possible, just swap in the clone disk and restart your workload, and you're back to that healthy state. So again, this optimizes this flow where otherwise you would need to copy the data up and down to a snapshot to get back to that saved pre-upgrade state. Okay, so let's switch to high availability. So regional persistent disk is our offering here. Provides some basics on sort of what it is and how it works, and then we'll talk about how it supports different kinds of failure scenarios to provide high availability. So regional persistent disk provides synchronous replication between two zones in the same region. So what that means is that as a workload is writing to a disk, there's a second replica of that disk in another zone. And we ensure that that data is committed on both sides. So what that means is that if you have a single failure, let's say you have a network disconnect or a sustained outage in a zone, your recovery point objective can be met at zero data loss. So versus, let's say, using snapshots where you may take a snapshot, then if your workload is destroyed or has some sort of outage, you can always restore your snapshot, but the amount of data loss that you would have with the snapshot scenario would be the amount of time that elapsed between when you took the snapshot and when the outage occurred. Here, using regional persistent disk, your RPO is 0. This is designed for maximum availability. So what that means is, let's say that your failover zone becomes unavailable. We still maintain the availability of the workload in that primary zone. So again, we favor maximum availability, which also means that if you have an outage in one zone, let's say in your failover zone, your data is still running and intact with no data loss in your primary zone, but you'll want to take some mitigations. We keep your workload running even when one of those zones goes down. The other thing I want to emphasize is This offering provides additional replication between two zones, but every persistent disk, zonal persistent disks, meet or exceed 3 copies within each zone for additional durability. So just a little more detail on the failure management that I was outlining. So you can imagine 2 scenarios. One is if you have a failure in your primary HA zone. We recommend using health checks to determine if backends are responding to traffic. So that's the way you would detect if there's a failure. If there's a failure in your primary zone and you want to fail over in the secondary zone, the recovery time needed to attach that disk to a failover VM will typically be a minute or less. So again, the data is replicated to the secondary zone, and you'll be attaching a VM to that disk. It's actually one logical disk that's represented in those 2 zones. The actual RTO that you achieve will depend on how you manage your VM. So, for example, if you have a hot standby VM that's running all the time versus a VM that you need to start, that of course will affect your recovery time objective. In the scenario where a failure occurs in the secondary HA zone, if you're thinking about a primary secondary pair, then again, the data that you're continuing to maintain in your available primary zone is there, but you've lost your HA protection because your secondary zone is now down. So in that case, the best practice, and in fact, we would always recommend this best practice, is to use scheduled snapshots. So scheduled snapshots can ensure that you're at least bounding your recovery point objective, even if you have that secondary zone become unavailable, so that if there is then a second failure, let's say there's a regional outage or some other sort of loss, you now have snapshots as an additional layer of protection. The other thing that's important to know about regional persistent disk is catch up and failure recovery is automatic. So let's say there's a network outage in replicating to the second zone. Once that's resolved, the replicas will automatically be caught up and brought in sync. Okay, so let's talk about some best practices for these features. So the first point we made in the context of clones, avoid temporary snapshots whenever possible. So again, we know that for scenarios where the goal is to create a new disk immediately, for the scenarios that we have described, copying back and forth to a snapshot is a waste of time and also a waste of resources and an unnecessary cost. So you can use clones for much higher performance and cost-saving benefits. The second best practice is if you want to very quickly create new disks, especially across region, images are the best resource for that. So again, if you have a single data source and you want to very quickly create large numbers of disks, including between regions, images are optimized for that scenario. So there's local caching that we do in persistent disk in any target zone where you're starting to create new disks, and you'll see much faster, high-performance disk creation. The third best practice that we talked about in the context of regional persistent disk, but applies really everywhere, is to schedule hourly snapshots for backup and disaster recovery. So we have a built-in scheduled snapshots capability. This is a great way to limit any risk of data loss if there's, again, some outage or disaster or human error. The other thing to consider is some customers like to take daily snapshots, which is great. If that frequency can be increased so that snapshots are taken, let's say, every 6 hours or 12 hours instead of daily, that will lead to smaller uploads rather than uploading all of the changes for the last day, and that'll support faster snapshot creation times. Okay, so hopefully this will be useful as sort of a reference chart in thinking about scenarios, features, and what they're purpose-built for. So again, snapshots we really think of as optimized for long-term data backup. You can find pricing information on our website, and again, information about exactly how we manage full snapshots and then incremental chains of those snapshots as you take more snapshots from the same disk. And again, if what you need is geo redundancy or long-term backup, it's the best option. If the goal is high availability, regional persistent disk is purpose-built for that. It's not built for backup. So again, if a region is somehow completely unavailable or destroyed in some way, you would need snapshots in addition to regional PD to have that durable geo-redundant backup. But regional persistent disk gives you that 0 RPO for a single failure and that very low RTO. Again, disk clones, also not intended for disaster recovery. Those are optimized for efficiently creating new disks in the same zone from a production workload. So again, we talked about the examples of export offloading, forking data into staging very frequently, optimized for that purpose. And then as we look at Google Machine Images and the guest flush option, those are optimized for consistency. So whether you need consistency across multiple disks that are working together to support a workload on one VM, or whether or not you want consistency up into the guest itself, again, for application quiescence or verification, or additional information or additional information and control that's only available inside of the guest. And again, looking at it from the scenario perspective, just to recap, backup and DR, we recommend using snapshots for efficiently moving data within a zone to bring up new workloads. We recommend disk clones. And then for high availability, regional persistent disks. And then we have these two options depending on the nature of the application consistency that you need. So thank you very much, and we look forward to hearing your feedback.